I'm Frankie Nicoletti. Why am I doing this talk? To reduce future terrible MVPs, because probably a lot of people on this call have dealt with them, but also, the kinds of talks that I do at this point in my career are attempts to create the kinds of engineers that I want to hire, right? So it's a little selfish too. It's that I would like the next time I have to handle an MVP, I would like it to be a little bit better, and I want there to be a lot of engineers in the market who are interested in building more sustainable software, right? Those are the engineers that win when your company is ready to grow and expand and all of these things. I think sometimes the tech industry takes the hacky MVP stuff a little too far into a company's lifetime, and then it becomes really prickly to uncover some of these problems. So, what are we talking about today exactly? So systems thinking is it's a philosophy. It's sort of the opposite of reductivism. Reductivism is the idea that you can take something complicated and reduce it into its individual parts and deal with them individually. A lot of microservices architectures are sort of designed with this in mind, where they're like, well, if we just separate them out into individual pieces, then we'll be able to deal with those one-on-one, and then when they come together as a whole, they'll work. And so that's sort of the individualism idea in tech, is like, well, if we just break out the pieces, we can deal with them separately. And a lot of times what can happen is that you can't see the forest through the trees, right? You're so focused on like the one at a time, then you haven't like thought about how they all connect together. It's not to say that all microservices is bad, or even that all mono repos is bad. Both of those are just tools that you can use. And if you don't have your sort of organizational principles in place with everyone agreeing to them, it doesn't really matter which one you use, because you're still going to have problems. So there isn't like some specific architecture like that. And for the purposes of this talk, we'll be talking about an API, and we'll be talking about it in the context of one service, which you could later break out. But for MVPs, you're probably not building enough of an API to warrant multiple repositories for that. This is about looking at everything together. And so why MVPs? Well, it's a big part of our jobs if you work at startups. But also, Gall's law states that all complex systems that worked evolved from simpler systems that worked. So if you want to build a complex system that works, you have to build the simple system first and improve it over time, which is really what MVPs are supposed to be. And they are the simplest version of the thing that works. So it makes it a little bit easier to sort of talk about things, because there's less code written, and you're trying to do very specific things first, right? Because you need to show it to investors, or you need it to work for customers, but like your scope is smaller, which gives you more space to spend a little bit of time on your things like your organizational structure. So the first thing that we're going to talk about when it comes to our systems thinking, that you got your MVP that you got to build, it has a couple things that it needs to do. And it's very tempting, because it doesn't seem like it's a lot of things to do, to put it in fewer packages. And I strongly urge you to put more organization into this initial part of your MVP than you think you do. Because I have seen MVPs that range from, we just put everything into one file. It's cool, right? And that one file included a ton of concurrency that was not really working properly. It was just like a massive like ball of like, I don't know. So it feels like a little bit more work to set up a little bit more structure in the beginning, but the fact is that it will save you like exponential amounts of time later as you go in to add things, which we'll see a little bit later. So like, right, you put everything in a separate package. In fact, I only put in the main package, like it grabs the NVVARs, it makes external connections, it kicks off the server. That's it. Everything else goes somewhere else. Because it's really obnoxious to have to move things into different packages later. So it's better to separate all that stuff earlier, right? So you have at least like you have your types in a separate package. And for people that may not be writing like Go all the time, right? If you don't put your models in a separate package, you can end up in import cycles. And there might be other stuff in between, depending on how much business logic you have, right? I'm working off of MVPs at my current job for a couple different things. Some of it's logistics software, some of it's e-commerce. But e-commerce is the one that's really top of mind because that's the one we just rebuilt. Because one of the things you might choose to do is not to fix your current MVP, it's just to do it from scratch again, which we have done. And so you have your sort of your API, you have your database, and then you have like specific services in the middle. Resist the urge to dump all your business logic into one package, because your business logic is going to grow, right? And then you're going to end up with this big mess of things. I'm a big advocate for Go packages to be on the smaller side. Files should be small, packages should be small. Only like one concept per package, which means that like there's an order service package and like a product or a shop service package, but those two things don't go in the same place. And the reason for that is that it's clearer to see what is calling what the dependencies are, and it's easier to know where to put new logic. One of the things that was really frustrating in the MVP of the e-commerce side of the app at Zero was that all of the business logic had been dumped into one package, and it included the payment processor. This is a normal thing to happen with MVPs, because especially if it's written by people that didn't really know Go very well in the first place, is they did things to get around sort of the natural separation that the language wants you to do. And so instead of having a payment package like that talks to Stripe, all the Stripe stuff is integrated with the service. And it makes it really difficult to even tell which code is still in use, let alone, develop those clear lines. I'm not even sure we can pull it apart. I think that might be a rewrite later too. But we're picking at it. We worked on the e-commerce part first, which we ended up rewriting. So your package structure matters, even if you don't think you're about to write a lot of code. And then people love to make choices with MVPs where they can avoid defining their models. And I'm a big SQL fan, right? Like I'm not going to use Mongo unless I absolutely have to. But people use Mongo because they don't have to clearly define their data type in advance. And I can sort of understand that, but I think for something like, and it's going to depend on your use case, right? But for something like e-commerce, there's some pretty basic, like, what a user is going to include, right? What a product's going to include, kind of what goes into an order and some basics of inventory management. Like those are not unique to Zero. Those are, we sell physical products. So there's probably more of your data model that you can have sorted out than you think you need to. And I think people should spend a little bit more time trying to build those in a way that you could add on to them later rather than avoiding them. Because then when you have to go through and audit your data types, you have all this gunk built up because you're not sure what was added by what. Like you got to give yourself room to grow. And then I'm a big advocate for having your unexported types in like your API and your database packages that let you, all your JSON marshalling happens there, and then all of your SQL, if you use SQLX or struct tags, or your like null string if you're using like, regular Postgres, and not trying to do those in the universal models package. Because what happens is you might have a data structure that changes, and you might want to do some transforming before you change it all the way through. And if you have one data type that is supposed to handle all of that, you end up having to manage weird things like, or you have to like build a custom marshaller or something. But trying to keep it separate. This is a very clean architecture kind of concept, right? Where there's very heavy interfaces between things that make external connections, which both the API and the store are, versus like what's being used in the internals. And I think it's very, very underrated. Because what can happen once you have these separated out is that if you need to make changes to the database or to the API, right, you can do things in pieces without having to do it all at once. Because the way that the API at Zero goes is that it uses one model type that has like 3 or 4 struct tags after it. And so every time you want to make a change, you have to look at where that model is used in the entire code base rather than just in the handful of like separated scopes where it exists. And that, even that right there will sort of eat up whatever time you thought you saved by writing a hacky MVP. So the goal is we want to be able to do a little bit more work front loaded and then be able to spend less time on some of these decisions later. So you're not like doing some stuff and just making sure it works and then walking away and coming back and being like, oh, now I have to think about this, but some of it's already working. It's a lot easier to think about this stuff when nobody's relying on that software yet. And then, interfaces are a big part of Go. I'm a fan of using structs. So my API is a struct and I can set things on it in the main package. I say, this is the API it's using, this is the database, whatever. And it's really easy to follow the flow all the way down to see who's using what, rather than everything being jumbled up into one package or one file and saying, I don't know which pieces of this code base this particular API call needs. You should be able to track it all the way back. Very straightforward. Zero's current interface, most of them aren't hooked up and they're using a lot of just functions that are exported in the package. And it's very difficult to sort of figure out what's still in use, who's calling what. I like to be very explicit about who needs which pieces. And even though it takes a little bit more time to set up, it's a lot easier for someone else to pick up later and for you to figure out like how to add a new piece of code. But they also let you do things like swap things out. So, one of the places that I worked, it was sort of like Squarespace, but for direct response marketing. And so our customers were building like 50 microsites instead of like one Squarespace site. And so we had a couple like APIs like, I don't even remember what it's called now, but there are these places where Unsplash, right? Places where you can get high quality images for websites for free. And, we had a couple of them. And so we built an interface so that you could hook any of them up to it and it would just work. The other benefit of that is if you decide you want to change something out, if you've used interfaces together, then you could just build something else that fulfills the interface and you only have to change the code inside that package. We recently had to upgrade some of our Stripe APIs. And that code was like all sort of spaghettied in there. It should have been the case where it was just only the Stripe package needed to be modified. But it's not set up that way yet, right? But if you set that sort of thing up in the beginning where your whole, if I was building an MVP from scratch, the payment processor code belongs in one package. And then you export the things you need from there. But that way, when you decide to pull that out and replace it with something else, you only have to change the one package. So it's a little bit like separations of concerns, but that using the actual Go interfaces allows you to swap things out a little bit more easily. It reduces the amount of code you have to change. Also, it helps you test. Writing tests in Go can be really, really easy if you are using interfaces instead of passing around the actual struct, because then you just write a whole mock test struct and you fulfill the interface. And you can use that to help you mock your functions. And there's some very elaborate things you can do that are really easy and straightforward to code if you have set it up to use interfaces. If you have set it up to use like the actual like structs or it's importing exported methods from the package, now all of a sudden it's very difficult to sort of mock your database or something like that when you're testing business logic. So interfaces feel like a lot of work. Trust me, they're worth it. And also interfaces provide a little bit of self-documentation, right? You could say, well, this is the interface for what the database does, and it's literally a list of all of the method signatures of what's already available. And that's very helpful too. And then separation of concerns, which all of this is sort of related. These bullet points are fairly arbitrary. They're all sort of coming back to the same thing, which is it's really about how you organize, right? And separation of concerns, the organization when you're talking about this deals with this, so this thing doesn't need to know about it. And that gives you a little bit of like division, so you can focus on making this one part work. but it's still thinking about how they all connect together, right? So this is your file directory structure. You know, the way that I usually structure these is you have main, this is your environment variables, this is you connect to external services, this is where you panic on error. The only place that I support panicking is in a main.go package. It's on the startup of the service. You can't connect to the database. No point in running the API. Panic. Fail fast, that sort of thing. It's very scary to me to see code bases where there are random panics thrown in other places. I think that probably there was a different way to do that so that your code can't randomly panic somewhere you didn't expect it to. You know, and then the API is a package that I want all the JSON marshaling in there, all of the like errors that are returned in the, you know, the HTTP response go in there. You got your database, which is all your database types. And like there's, you can't access the database at all outside of that package. It would be the same with, you know, a package like Stripe. I would call it something more generic, like a payment processor. And then you put all your Stripe code in there, but then you don't import anything related to Stripe anywhere else. Keeps it organized. It reduces the amount of code you have to change should you decide to swap it out. It's also really easy then to see what you already have in terms of, you know, the next feature that you're going to build, like whether you are set up to support that or not. And then additionally, I think business logic belongs in, you know, sort of whatever the entity, whether that's like, you know, you might have like an order service and an inventory service, and break those up like that so that all of your intensive business logic lives there sort of in this middle thing that does a lot of importing, and the API calls it and it calls the database, and then it might connect to other libraries. This is also very clean architecture-y. And then, you know, you might have shared libraries too. Isn't really like, we don't really do like util packages in Go, right? We prefer things like you put the utility functions unexported in the bottom of the file that uses them, rather than trying to pull all your utility functions into one shared library. And it's tempting to want to put it all in one place in the beginning because duplicating code makes people unhappy, including me. But what happens then is if you need to make a change to one of those util packages and it's used in 50 places, it's better to just like keep it in the package, even if you have to copy that function a couple times because you need it a couple places, because you don't know how that needs to evolve. So don't try to overuse like trivial utility functions. Just put them in the bottom of the file, and then you have full control over what that thing needs to do for that package, rather than having to then suddenly worry about how many other files your like, you know, sense to float function is touching. Just put it where you need it. You know, but like if you have UUIDs, you probably have a suite of methods for UUIDs, or a payment processor, put those in their own package. And then your separate models package, which is, as I mentioned before, how you prevent import cycles, but it's also it makes it really easy to do things like add a protobuf data model library, which, you know, Zero will probably be doing eventually. Because what if you haven't used one of those before, you know, protobuf is language agnostic, and what it lets you do is create your data types in a central location and then run a little script, sort of think like when you have SQL migrations, and it will transform that data type into whatever language you're using. So you could have shared data types between like a TypeScript and a Golang service, because the protobuf will handle unpacking that type into that language. And it's great to be able to, if you're going to do that, to have that just affect one package and not a thing that can suddenly affect like all kinds of places in your code base. It minimizes, you know, side effects and things like that. So protobuf libraries are cool. And so the flow for this then has a very standard, again, it's very clean architecture, right? API, business logic, database, and you could sort of think about that as one vertical. This is that integrative, you know, idea where we're looking at like, what does this actually look like from the API to the database and then back out again, rather than, you know, either sort of jamming everything into one place or trying to separate it out too much. You still have to remember at the end of the day that there's a line from the API to the database and then back out. And then the other thing that structuring your code like this, and even if you don't do this exact thing, if you have some other sort of structure that everyone agrees to, it makes it easier to figure out where the next set of logic goes. It's easier for new people to pick up the code and understand what the heck they're doing. It's easier to debug. It's fundamentally, as long as what you're doing is consistent, it's better than just throwing some things together. But taking that organization a little bit further, it's going to make your life a lot easier. It's easy to rip out and replace, right? If you're a startup, you might be using, XYZ tools, and as you grow, you might outgrow them and you want to replace them, or you're like, well, this vendor, this is too expensive now. We can save money if we do this, or they can't quite handle our volume. We need to, we've all been there. You outgrow services, you need to replace them. And it's nice when you have to do that if you only have to change code in one place, as opposed to having to change it like across 50 files. This is where I wanted to talk a little bit about concurrency. If you've gotten this far with your MVP and there's a place where you say, actually, these two things could be done at the same time, this is the part where you are then maybe throwing in a little bit of concurrency that's very well documented. Unless you're on a team with like several senior Go devs, which if you're in DC is very uncommon. Other people are going to be touching your Go code for whom Go is not their main programming language. And if you make them debug concurrency, it will give them a headache. So if you're going to do that in code bases that other people are going to touch, especially when it's MVP and things are supposed to still be pretty straightforward and simple so that you can build on it, just, keep that to a minimum until you actually need it. And then really well commented, because Go concurrency it's sort of difficult for people that come from JavaScript and front-end stacks to sort of wrap their head around. And at least for most of the startups I've worked at, it's more important that other people be able to look at that service and figure out what's going on than it is for me to have done something that saves a very small amount of time. Software's a people problem, right? It comes down to who else needs to interact with this who isn't me. So I can't just do it in a way that makes sense to me. I have to do it in a way that's going to make sense to other people. Now, side projects, that might not be the case. But maybe your side project then becomes some big open source thing and you do want other people to help with it, right? But definitely in professional settings, software engineers work on teams. Other people have to touch your code. You have to touch other people's code. And so we can all be a little kinder to each other and at least like agree on things along in the organizational structure, and then we can comment things out and not make things more complicated than they need to be. I feel like at this point in my career, I find myself frequently being like, well, that sounds like over engineering. That sounds like we're doing too much. Like, let's get back to like the root of what it is we're actually trying to do, and then do the simplest version of that first. And then you can optimize it later. But I think people start writing Go and they get overexcited and they're like, oh, we're going to do concurrency. Go's pretty cool without the concurrency too. And it's more important that the software work and be maintainable. I will get off my soapbox now about concurrency. There are absolutely some times when you should use it. And if you have multiple engineers on your team that are really familiar with Go and they know how to debug it, that's awesome. But that's not always the case. And you got to build software that's maintainable by the rest of the people on your team. Okay, so let's talk about scaling, because this is hopefully what's happening next, right? With your MVP. You built your MVP, it's working, you got customers, everybody's super excited, and now you need to make it do more things. So there's a lot of things that could happen next, right? I need to add a new vertical, right? So you had your models, your API, you know how to do that line from API to database and back up again. So you can just add those extra pieces that you need. Your data structure is changing. Well, depending on if it's just like you can do it in pieces, right? Be like, well, the data model needs to look like this. We haven't changed the database yet, right? And then you can modify transform functions and you don't have to make that change all at once. You can do it a little bit more gradually. Tests, as I mentioned before, tests are really, really simple, and VS Code makes it even extra easy because you can just run a single test by clicking on a button in the file. If not, Go has a pretty good test suite like of terminal commands anyway, where you can run one, you can run them namespaced, right? So like in a terminal, you could, this is why it's good to like name all of your tests, you know, you have to start with test, and then maybe the name of the function, and then the specific thing that you're testing, because you can go into your terminal and you can literally just type the first part of the text and it will run every test that starts like that, right? So Go's tooling for testing is pretty good. So what we want to do is take it that one step further and make it really easy to write your unit tests. And so if you have an interface for your database and you're going to test your business logic in your like order service, you create a version of your service struct and you set on it something else that fulfills the interface for your database, something that has allowed you to determine what those functions, you manipulate what those functions return, test what their inputs are, and then set their outputs by hand in those tests. And that really makes testing a lot easier. And that's probably a topic for an entire other talk, but we can talk about that later if you have questions on how that works. But it's pretty sweet. One of the code bases that I'm working in right now doesn't really have enough separation of concerns to be able to do that right away. And so, you know, writing tests at the moment is requiring any test for the services package to actually call the API directly, because it's very difficult to mock it and everything is sort of jammed up into the same packages. But we're going to move in the direction of being able to write better tests. You know, the other thing about being at earlier stage startups is that you know, tests are not frequently a thing that are built early on. And one of the reasons is because it's difficult. And then by the time you wish they were there, then it's going to require a lot of time to go back and stick them in, whether those are your front end or your back end tests. And anything you could do to make writing tests easier earlier is going to be better, you know, because if you don't have tests and then you're a startup and you don't have QA engineers and whatever, you know, your deployments start to become really risky because you don't have any of those safety nets. They haven't been built yet. So make it easier on yourself to build those safety nets. You know, or you might, as I mentioned, need to replace a service provider. Like say you're moving off of Stripe and onto Shopify, you know, great. You only need to update one package now because you can make that new provider like fit the existing interface you've already written. And that means that it will work everywhere else. It also helps you figure out where logic needs to be put, right? Which is part of the cognitive load of working in a big code base, is figuring out where something belongs. And if you don't have good organization, it can be pretty difficult actually to figure out where something belongs. But if you've done the work to sort of divide things up, then everybody on the team knows what kinds of stuff goes where, right? It's related to what's received or returned by the API, you put it in the API. Calculated or stored by the DB, you put it there. Is it like shared concept set of methods, or it's a you know, data type changes, business logic, helper functions? Like you can sort of see the map of this, like choose your own adventure, you know, we're going to do this, then this is what happens. And it's not like every time you approach that code base, you're like, oh, well, I'm not sure where to put this. It's clear where to put these things when you have this organization, which means that while you might take a little bit of extra time doing the organization when you first build the code base, when you start to get to that scaling space where you then need to add a bunch of features and you need to do X, Y, Z, it's a lot easier for you to do that. And if it's easier for you to do that, then it's also easier for you to estimate the project. It's easier for you to like communicate out. It's easier to debug. There's all of these benefits to just adding a little bit more organization than people usually do for MVPs. This is just, and this is not the only way to do this. This is just the way that I've done at several companies and seen work really well. And if you are familiar with clean architecture, some of this stuff looks familiar, right? But the main thing you need to understand about clean architecture is that it uses interfaces to talk to things so that it limits the amount of changes you have to make when you are modifying something. It's either in the business logic or it's in an external connection, all these things. So this is an example of how you get that, where you know where everything belongs, everything has a home. It's like Marie Kondo, right? If everything has a place to go, that it's easier to clean up rather than having to like sift through the closet of stuff to try to figure out which box you need to store this sock in, which is sort of what happens when we try to go in and make changes to MVPs that were not well organized. Okay, so I just talked about this. Adding new logic becomes easier. There's less cognitive load. It's easier to debug. You should still lint and comment your code, but at least you'll be in better shape when it comes to some of those other kinds of decisions. Or you could be here. This is where I have been on many occasions in my career. This is where you start to really pay for some of those decisions that were probably made by people who aren't there anymore, right? These decisions were made by engineers that aren't at the company anymore, or they work on a different part of the stack, or there seem to be a sort of two camps of engineers, where there are the hacky, scrappy engineers who want to work at very early stage startups and they don't always stick around. And the downside of that is that then they're building software that they don't ever have to maintain. Somebody else has to come in and maintain, right? And then you have the engineers that want to build things that are sustainable and maintainable. And sometimes the drawback to those kinds of engineers is that they don't always know when like is good enough. Sometimes they optimize for things to be a little bit too polished. As an IC, I fall into the second category, where I want to build it in a way that it's easier to maintain later. And a lot of times that's great. And there's a handful of cases where like you really need to like scope that differently. So neither one of those engineers is necessarily better or worse. Like they both have their purpose, but it's kind of a bummer when somebody writes a bunch of hacky MVP code and then isn't obligated to maintain it in the future. And so they don't think about that. And I certainly look to hire more of the second engineer, because I think it's easier to coach people. Done is the enemy of shipped than it is to, help people create an organizational structure in their brain about how to build sustainable software. But that's just my opinion. Right. So sometimes there aren't clean lines from API to the database, and sometimes things are like a junk drawer package where everything is all jumbled up together. I've seen some really creative things to get around some of the built-in separation of concerns that Go tries to give you with the packages. Like I've seen API request and response types outside of the API package, like looking like models, and they're imported everywhere because somebody was trying to get outside of an import cycle and they weren't willing to do the work to sort of say, well, this stuff needs to stay in the API package versus this goes into the service package. So they just got around it. So now instead of just having models, I got requests, I got response, and they're all like root level directories and they're everywhere. And it's not even practical to try to refactor that. What's happening, because it's so much code at this point, that it was better to just sort of start peeling the verticals off and putting them in a new repo, rather than try to like mess with that, because it was too much spaghetti. Sometimes you have models where the struct tag, they have all the struct tags on the same thing, and then if you need to like start changing that data model for whatever reason, like maybe you're switching from Mongo to SQL, and instead of being a UUID, the ID is, an integer from the SQL database, and so if you only have that one type and you're using it everywhere, you haven't really given yourself any room to make gradual changes. It's very all or nothing. Or, sometimes there's no tests, there's no interfaces, everything's just exported methods in the package. You got vendor, something like Stripe that's in several packages, and it's not, you don't even have all of those methods like listed in one place together. Sometimes you have every package has like an init function, and every package is grabbing its own env vars. It really gives me a headache when I see that. And I'm like, oh, cute. So this thing could start up and then just fail randomly later. these are just some of the issues that I've seen with MVPs, and you can't fix them all at once. You will never be blessed with enough time to just refactor everything perfectly. Like no startup has that kind of money where they're like, you can just take 6 months and just rewrite everything. It's fine. No, you have to still deliver to customers. You have to continue to add new features. You have to do all these things while you refactor. So you have to choose your battles. You can refactor one package at a time. You can refactor one vertical at a time. Or as I mentioned, you could rewrite the whole thing from scratch, but that you will never have enough time to do that properly. In a previous role, I had taken a Go service where everything was basically in like one file, not like totally everything, but most things were in the main.go file. And I spent a couple weeks trying to debug it because by that point in the company's history, I was the only person that knew Go. The person that wrote this software wasn't there anymore. And I ended up deciding that I needed to do it from scratch. But the only way I was able to do that was to do it nights and weekends for a month. I just like side project rebuilt the thing myself. This is not a path I recommend. Like, you need your work-life balance. But that was the only way that was going to get done. And so I don't wish that for any of you. So usually you're going to have to like choose one of these other things, but hopefully you aren't looking at like a single main.go file that has all of the business logic in it. Hopefully no one on this call has to deal with that. Or like, the other thing is, if you're working on a team, which usually software is a team sport, right? Whatever you're deciding to do, you need to over communicate to the team. Good software engineers will attempt to make the code in the code base look like the rest of the code in the code base, because you don't want to be able to tell who wrote it. But what that means is that well-meaning individuals will sometimes go in and undo something that you did in a new style because they don't know that it's the new thing. It just looks like an anomaly. So you need to over communicate to your team like what the things are, so that everyone can start shifting in that direction, because you'll move a lot faster when several people understand the refactors that you're trying to make, and everybody can sort of do a little bit as they touch things. But that requires a lot of getting everybody on the same page and making sure that everybody understands why those things are happening. That's easier to do if you have a team with a lot of experienced Go developers on it. That's not going to be the case for all of us. So what I do in my current job is I will, like, as things come up, is I just blast them out to the team and say, all right, this is an example of something that's in our code base. We don't want to do it like this. We want to do it like this. And that way, as people go in and touch, they can make small changes as they're going through. It's not the fastest way to make this happen, but it will help you do it when you have to do it gradually, which most of us will have to, right? The startup game is that you have to make decisions and do things with limited information and limited resources, and you always have to do 5 things at once. So it's better to get everybody on the same page so that everybody can do a little bit at a time, rather than trying to find like space to do some huge chunk of it all at once. Sometimes you got to do that. But then you got to fight for that time for the team. So whatever you can do gradually is helpful, whether that's like one package at a time, or you get everybody like writing the same style, all those kinds of things. But by this point, all of this stuff is already going to take 10x more time than it needed to if the MVP had been written a little bit cleaner to begin with. Like, I really think in absolute terms, you will spend cumulatively less time front loading this work. Things are already functional in production and you can't break them. You're responsible for things like backwards compatibility. You have a front end that's calling this API now, right? So you have an API contract you have to maintain. So balancing refactoring in that environment is way more complicated than it would be to just set up your organizational structure earlier on. You got less time, you got more people, you got more things going on. There's just more variables. It just becomes more complicated as time goes on. And a startup I was at a while back, the one that had like the over 200 microservices, there were entire services in that infrastructure that nobody wanted to touch. They were so old and so overgrown, and they were so integral to the system that nobody was willing to develop against them. Nobody was willing to refactor. They were so terrified of breaking this core piece of infrastructure And engineering leadership was really reluctant to give us any time to rewrite it. And we're like, well, if you don't give us time to rewrite it and test it, like we're going to continue to have nobody who wants to touch it. Or when they do, they're going to just add a little bit of code and then back away slowly, right? By the time you're there, lots of things have already gone wrong. And now you have this service that is super necessary for you to conduct business, and nobody knows how it works. And that's a very bad place to be in. And that's what happens when you don't ever make that switch. But that company had gotten quite large in its like startup life, and they hadn't ever sort of switched over from writing MVPs to building more sustainable software. They hadn't made that like psychological switch in the engineering culture. So people weren't willing to do the thing that said, all right, well, how do I make sure that more people can develop against this in the future? Like people just didn't touch it. So that's bad. Try not to end up there. I'm trying not to end up there. Yeah, so over communicate, do one thing at a time, right? But you have to have an idea where you're going in order to start that process. This is where most of us will live. Most people don't get to write the MVP from scratch, right? And for a lot of people, the MVP was written by engineers that aren't there anymore. And then you're having to unpack someone else's code while it needs to still work, but you're also trying to add this new stuff, but you can't because it's difficult, because it's not well organized. There's a reason why like we all like roll our eyes when we talk about legacy code, right? Okay, so we went over, your like sort of clean architecture-y organizational patterns and why some of those are important. And then, what this looks like as you scale. And then you're already in a bad place. What do you do now? And the answer is take it one day at a time and over communicate. And I think that's about it.